Okay, welcome to video number 49 of the Diaries of a Coronavirologist YouTube channel. Today is the 13th of January and we are up to about 92 million confirmed cases of COVID-19 around the world, and we're getting very close to 2 million confirmed deaths. So this day in COVID history, my recap of what was happening this time last year. The 13th of January marks when the first case of COVID-19 was reported outside of China, with that being in Thailand. Around this same time, there's another notable date, which was the 11th of January 2020, when the first death from COVID-19 was reported in China. So in about a year, we've had almost 2 million deaths from this virus. So in my video last week, I was talking about the fact I was fortunate enough to receive my first dose of the Moderna COVID-19 vaccine, and I was talking about my experience of that. So on the Tuesday, I received the vaccine, and on the Wednesday, when I was recording the video, I was talking about the fact that my shoulder was very sore and I could only raise my arm about yay high before it started to really hurt. On the Thursday, I could get it up to about there before it started to hurt, so I was doing much better. And then by the Friday, I was feeling fine. And even on the Thursday, it was barely a problem. I went out for a run that night and that motion didn't cause any problems. I haven't had any other side effects from receiving that first dose. No fever, no headache, no muscle aches or anything like that. So apart from a slightly sore shoulder and my experience of becoming very lightheaded and almost passing out, which I get for every vaccine that I talked about in the last video, I had no side effects worth reporting. Now, as I say, that was just receiving my first dose, and I'm now in a period of waiting to receive my second dose in a couple of weeks' time to hit the proper dosing regimen and the timing regimen that has been set out to provide proper protection. Now that's going to be the topic for the video tonight. I want to talk about dosing and timing because this is something that's being talked about quite a lot at the minute, and I've got a few thoughts I want to share on that topic. But before going into that, I do just want to say about the vaccination. So I'm 8 days in, I received my vaccine last Tuesday, but I'm not protected yet. The body's immune response takes time to get going, and particularly in time to produce antibodies. So antibodies typically start to be produced about a week to 2, maybe 3 weeks after that initial stimulus. If it were an infection, it would be after the infection. For a vaccine, it's after receiving the vaccine. So I'm 8 days in, I probably don't have a particularly high level of antibody in my blood against the spike protein. In a few more days, I'll have some, and a few days after, I'll have even higher. But right now, I'm not fully protected by any means. So the reason I want to bring this up is that there will be, no doubt, stories, and I've even heard some stories already, of people who get the vaccine and then test positive for virus a few days later. That is an unfortunate situation. They've probably been infected before the day of or just after receiving the vaccine before they're able to produce an antibody response. So there is a bit of a lag in how the body responds to then be protected by this vaccine because it takes time to produce antibodies. The reason I bring this up is to make it clear that there will be stories about people who got the vaccine and then got sick within a short period of time, and that's just going to happen. It's very unfortunate. But I also want to make it clear that just because people are receiving their first dose of vaccine, and maybe you, dear viewer, have received your first dose, that doesn't mean that you're safe. It doesn't mean you're protected. You still have to be wearing masks. We all still have to be wearing masks. We have to physically distance. We have to wash our hands, all those same kind of things, because it takes a bit of time for the immune response to kick in. It's only after the second dose that we know that there is a good level of protection from these vaccines. So the 3 that are approved in the US and the UK combined, being the Pfizer, Moderna, and AstraZeneca vaccines, they've been shown that after 2 doses, spread 3 to 4 weeks apart, they are effective. Now, I'm stressing words there because the topic for tonight is looking at this dosing and the time between doses. So in the UK, after they authorised the use of the Pfizer and the AstraZeneca vaccines, they've decided to change the dosing regimen to 12 weeks in order to vaccinate more people, to get more people their first dose. In the US, there's also discussion of doing similar things. There's discussions of using a half dose the first time and a full dose the second time. There's discussions even going around of mix and matches of the vaccines that have been approved. Now, I have some problems with it, and that's what I want to talk about in the video here. The reason that these ideas have come out, though, is there are good reasons behind it. There are good arguments for doing things like spreading out the dosing or doing a half dose. So I do want to look at some of those, but just to make everyone aware before I start to talk about the potentially good aspects, I do want to make it clear that I am coming from this with an angle of I don't think it's something we should be doing. And of course, I'll explain why that is. But first, allow me to talk about the positives behind this idea of maybe doing a half dose or extending the doses. So if we take, for example, halving the dose, that's a simple maths problem. If you half the amount of dose you need, you can vaccinate twice as many people. And there's a huge excess of people who need to be vaccinated against this virus in order to limit spread compared to the amount of vaccine doses we have. So the more people we can vaccinate, this is definitely better. And there is some data that suggests that lowering the dose or only having one shot instead of the two may be protective. Both the Pfizer and Moderna vaccines have some data that do suggest they might be between 80 and 90% effective if you just receive one dose. So if you're only given one dose, that's equivalent to doing a half dose in a sense. So maybe it's good and we can get more people vaccinated at 80 to 90% protection, which is very good. It's about a 10% drop to where the two-dose regimen is, because both of those are around 95%. But there is some data that suggests that maybe one is enough. However, those data are from a very limited number of people. The studies were set up to look at a two-dose regimen, and very few people in those studies only received one dose. So they're making these claims of 80 to 90% efficacy from probably, I think it was around 30 people in the Pfizer vaccine. That would not be enough to approve the vaccine. The numbers that were laid out at the start of the trials were to do 150 cases across the placebo and the control. So they're nowhere near the level to make these claims with any statistical significance. But that's a reason why maybe we could just use one dose. Maybe it does work as well as it seems to, and it means we can vaccinate many more people. And in terms of the delay between the vaccine doses, there could also be a good reason to do that. So as I was saying, it takes a bit of time for the antibodies to come up in our system after receiving a vaccine, and we actually need that all to calm down a little bit. So it needs to go up and then come down a bit before the booster is effective. So the idea behind the booster jab is that it really ramps up to an even higher level, that immune response that we generate the first time around, but we need the first one to wane a little bit before we get a true boosting effect. Now, most data suggests that that waiting time is about 3 weeks to 4 weeks, which is why the protocols were set up to use that length of time. And it's possible, maybe, that a longer period of time can have a higher boosting effect. As the response goes further down, as time goes on, maybe you get a better rebound. And probably over a 12-week period, let's say, because that's what's being used in the UK, you're not going to go to such a low level that you become unprotected. You're probably still going to be very well protected against SARS-2 in that 12-week period, that 80 to 90% I was just talking about for the Pfizer and Moderna data, such that you may have a more effective boost. Now, I'm using a lot of words like maybe and probably, and I will come back to that momentarily. But just to stay on this idea of delaying and extending the period of time between the doses, the priming and the boosting, that may actually be beneficial, specifically in the case of the AstraZeneca Oxford vaccine. So that vaccine is slightly different to the Pfizer and the Moderna vaccines. I've talked about it all on the channel before. I've got old videos that I'll link to down in the description for this if people want to go back. But the Pfizer and the Moderna vaccines are both mRNA based, and they are transported into our cells to produce the mRNA that make the spike protein that our antibodies see to protect from SARS-2 infection. And that delivery vehicle is just some fat molecules, some lipids. The delivery vehicle for the ChAdOx vaccine, the Oxford vaccine, is chimp adenovirus. So Chad, chimp adeno, and Oxford, ChAdOx. So the delivery mechanism there is another virus. Adenovirus is another type of virus, and it's a virus that infects chimpanzees. But we can use it to deliver the genetic material that allows our cells to produce the spike protein to trigger our immune response in the same way that the mRNA of Moderna does. Now, the problem there, potentially, for delivering the booster is that our bodies can also mount antibody responses to the chimp adenovirus. So if we have antibodies that target the chimpadenovirus and we put in the second dose of the vaccine, those antibodies may block that second dose of vaccine doing anything. It may not be able to get its genetic material into cells and therefore doesn't work. As a metaphor for how you could think about this, the chimpadenovirus is like a taxi, and a person sat inside that taxi who's going to their destination is the genetic material for the SARS-2 vaccine. And the taxi goes once and everyone sees what a taxi looks like, and then the second time it comes around, everyone tries to block that taxi getting to its destination, so therefore it's a useless taxi. The other vaccines, they're just normal cars, no one notices them, but a bright yellow taxi, let's say a New York yellow taxi, that gets seen and everyone can block it. Now, it's not certain that that's what's going on, but if that is going on, then maybe a longer period of time between the first dose of the AstraZeneca vaccine and the second dose would allow those antibodies to wane more, so there's less antibody that's capable of blocking the virus, and therefore you get a better boosting effect. So that would be like the people who are blocking the taxi, in my strange metaphor, there's fewer of them, and therefore the taxi is able to get through. Now, all of these are valid arguments and they're valid hypotheses, but that's the problem. They're all hypotheses. There is limited or no data to back up any of these ideas. So as I say, I'm very much coming from this from a stance of I don't think these changes should be made. I think there is merit to changing them, as I lay out with the AstraZeneca vaccine. Maybe we get a better boosting response if that's 12 weeks, not 3 weeks. But the trial looked at 3 weeks. Same with Pfizer and Moderna. Maybe there is a good reason to only use a half dose or only use one shot instead. Maybe it's just as effective. But that wasn't what was studied scientifically. These are all just hypotheses. And they're great hypotheses from which to go and do some science. Go and do the clinical studies to see if they work. And this is kind of the main crux of my argument of why we shouldn't be changing these protocols and why we should stick to what we've got, because this has to be rooted in science. The clinical studies that were done showed these vaccines to be highly effective at preventing severe COVID-19 infections. Changing them on the fly is not the way to go. Why bother doing the trial if you're going to just change it on the fly? It's better to spend the time to do the clinical studies to see if these ideas of half dosing or longer dosing are effective. And these ideas have been talked about since probably December. We could have a month's data on it by now. It's not too hard it shouldn't be too hard to set up a clinical trial to look at it. You could set up a trial where you enroll 30,000 people, like the phase 3 trials for this. You give half of them one dose of Pfizer or Moderna vaccine, you give the other half the 2 doses like normal, and you look to see which is more effective. It wouldn't take too long. There's a lot of coronavirus spread going on right now. We get the data very quickly to see if the 1 dose is as effective as the 2 dose. And in that scenario that I've laid out, there's not really many ethical concerns because everyone's getting vaccinated anyway. Similarly, for spreading out the dosing, it would be easy enough to just have one group who get a dose and then you wait 12 weeks versus one group that get 3. You're still vaccinating just as many people, but you're actually doing the science. You're not just changing things on the fly. And this idea of changing things on the fly is another concern I have, in that there's already a lot of vaccine skepticism and hesitancy out there. People already think this is being rushed. We as a science community have to do everything to explain to people, encourage people that the science is being done, make sure they understand why it's safe and effective. To change things on the fly could potentially really damage that. Now, that's a hypothesis. There's no data to suggest that changing things on the fly would reduce the amount of vaccine uptake, and maybe that's a study for the future. But I think it's so important that we have a clear message on these vaccines that we can't just decide, oh, cool, we've approved it, let's now wait another 6 weeks or 8 weeks, whatever it is, before we do another dose of the vaccine. Or maybe let's just give one. That doesn't ring right with me. That doesn't sit right with me. It has to be rooted in the science. And frustratingly, if we stopped talking about it and did the science, we could have data on this already. My other cause for concern in this area, though, is that we may be making the perfect recipe to produce viruses that are resistant to the effects of the vaccine. Every time a person becomes infected with a virus, that virus can mutate and it can change, it can evolve under natural selection. So any selective pressure placed on the virus, if it can infect a person, it's going to evolve to try and overcome that. And any virus that is a mutant and has a selective advantage will thrive. If we look at the one dose idea, it seems that there's about a 10% drop in efficacy for the Pfizer and Moderna vaccines, which means 10% more people could become infected. Those people are going to be infected by a virus that has a selective pressure put on by some of the antibody that's being produced as a response of the vaccine. People who get one dose of the vaccine produce antibody, and they produce antibody at a lower level than people who receive two doses. That's been shown in the data. So there's less antibody present, and there's more likelihood those people become infected, which means the virus could mutate to avoid the vaccine-induced antibodies. In the lab, if we want to study what kind of mutations allow a virus to escape antibodies, that's what we do. We put a virus on to infect cells in the presence of a low concentration of antibody and slowly increase that concentration of antibody until it's at a really high level and we still get virus infection, and we look to see what mutants have appeared and what mutants have been selected for. We may inadvertently be doing that experiment in real life by only giving people a half dose, or extending the time before they receive the second dose. Again, this is a hypothesis that may happen in people. It happens in the lab, we can show it in the lab, but out in people, maybe it doesn't happen. But it's running a risk, because if we start to select for viruses that can escape antibodies produced by the vaccine, we may very rapidly make all of these vaccines completely ineffective. It seems better to just go and give people the two doses of vaccine 3 or 4 weeks apart and not run the risk and get 95% of people protected. As I say, some of those are hypothetical arguments, similarly to what I was talking about with the arguments for doing this. My main point really is, though, that the science has shown that a certain level of dosing and a certain time is what's protective, and we should stick with the science. Just as a final couple of closeout points, I have a concern about these longer periods of time and it meaning people forget to go and get their second dose or lose the documentation about their first dose. When I got my vaccine, I got a little bit of card about this big. I'm worried I'm going to lose it within 3 weeks, let alone within 12. So there's a chance people forget to go get their second dose. There's a chance people get the wrong dose because they forgot what they received the first time. Those are all going to have issues. There's also a chance there won't be vaccine doses available if you give it a longer period of time. Recently in the US, there's been some talk that Joe Biden wants to change the situation of what's going on right now. So right now, half of the doses that have been produced are being held back so that everyone who's received a first dose can receive a second dose. Biden has recently been saying that he is considering that his administration may change that and release all of the doses. That I find concerning, because potentially that means there's not going to be doses available for the second. However, those concerns were allayed recently. I did see a study that suggested production would have to drop between 80 and 90% for that to actually be an issue. There are enough vaccines being produced. So maybe my concerns in this area are somewhat unfounded, especially if there's good electronic records and things like that. So maybe that's not such an issue, but it is something that does concern me a little bit. But that does lead me to my final point before closing out the video, which is that this is actually all a pointless argument anyway. Sorry you've watched the whole video for me to say that. What I mean is that, at least in the US, I'm not sure it's quite as bad in the UK, but in the US, the rollout of the vaccines has been a logistical nightmare. There are vaccines sat in freezers, doses of vaccine that are not being used and they're having to be thrown away. The vaccines aren't being rolled out quickly enough. At the current rate, to vaccinate enough people to give good levels of herd immunity against this virus to stop spread, it would take 10 years. That's just simply not good enough. It doesn't matter if we half the dose or we extend the amount of time or if we release more doses. If they're not going into people's arms, it doesn't matter anyway. So regardless of how the dosing is being done, if we can't get better at actually putting them into people, it doesn't matter. So just stick to the original plan. Like I say, maybe it's different in the UK. I haven't seen as much or as many issues with the rollout there, in which case maybe the UK should set up a trade deal with America for all of their wasted vaccines. Might be a good thing. But ultimately, until all the logistics of the rollout are worked out and we can actually put these vaccines into people, it's all academic anyway. And because of that, we might as well start the trials. We might as well start studying this academically and looking at whether half dosing or single dosing or extended periods of time between the dosing actually is beneficial, so that when we're good at putting vaccines into people, we know the best way to do it. We stop wasting time talking about it and just do it. To summarize my overall point, I don't think we should be changing with the policies that have gone through clinical trials. The clinical trials are there for a reason. They're there to work out if it's safe, to work out if it's effective, and the right way to get that efficacy. To change things after the fact is wrong, and we should do the science. It should all be backed in science. I'm very disappointed to see that the UK have decided to just extend the time between vaccine doses. I'm glad that here in the US, the FDA have said that they're not going to change anything until there is science to back it up. That's the way I think it should all be done. I call this channel Diaries of a Coronavirologist because I'm a coronavirologist. I study coronaviruses, and today was very much an opinion piece, I guess, of me ranting about science, but this channel is about talking about what's going on with coronaviruses. Anyway, with all those things said, thank you for watching. Please drop a like for the YouTube metrics if you found the video useful and interesting. Please leave comments and questions down below if you want to add anything, if you want any clarification on anything, and subscribe if you're new around here and you like the videos. As always, please stay safe, wash your hands, wear a mask, and keep calm and carry on. We will get through this pandemic.